Okay, welcome. This is 10.1. Whoops. Try that again. This is 10.1, and the subject of this is multiplying powers with the same base. Multiplying powers with the same base. What we mean by this is when you have a number like 2 to the third power, this number that's on the bottom of the exponent, not the exponent itself, but this number, that's called the base. So when we mean multiplying powers with the same base, we're looking at an example that's like 2 to the third times 2 to the second. So that's our example. So what I want you to do first is I want you to do these examples, real quick examples. We got 2 to the second. I want you to tell me what that is. 2 to the third. What's that? And 2 to the fifth. So I want you to solve these and see if you get any kind of pattern. And I also want you to do this one. Do 3 to the second times 3 to the third and 3 to the fifth. So solve those out real fast. And my question for you is, do you notice a pattern? Do you notice something, a relationship between this number, and this number? So 2 to the second power, that's 4. 2 to the third power, that's 8. And 2 to the fifth power is 32. So if you're looking, 4 times 8, when we multiply those numbers together, we get 32. But also look at the exponents. When we add 2 plus 3, we get the exponent of 5. Do the same thing over here. This is 9. This is 27. And when we combine this, we get 243. 9 times 27 is 243. And 2 plus 3 gives us an exponent of 5. So what this is called is a power rule. A power rule says if you take two numbers with the same base, so any number a to the n power times any number, the same number a to the n power, all you can do is you can simplify it by combining the exponents, the n plus n power. The reason for this is, let's say we have a to the second times a to the third. Really, all exponents are repeated multiplication. So a squared is a times a. And a to the third is a times a times a. So altogether, we multiplied a 5 times, and we get a to the fifth power. So that's our power rule. The step that we need to remember, this is from Math 1, is that anything to a negative power flips across a fraction bar. So what do we mean by that? Well, you got 2 to the negative 3 power. The way we get rid of a negative exponent is we look at this fraction bar and we bring it underneath it. So this becomes 1 over 2 to the positive 3 power for an answer of 1 over 8. Another example of this would be like 2 to the second over 3 to the negative 2 power. 2 to the second is a positive exponent, so it stays on top. So this is 2 to the second. Since the negative exponent is on bottom, it needs to go up above the fraction bar to get rid of the negative exponent. So this is 3 to the second power. Left under here is 1. 2 squared is 4. 3 squared is 9 for an answer of 36. So those are just some examples of this. So, quick example. Let's say we get 2 to the second power times x to the second times 2 to the third times x to the negative fourth power. So here's our example. What we can do, because we're multiplying, remember 2 times 3 is the same as saying 3 times 2. So we can switch the order of these around. So I'm going to switch these two around so that way I get the equal bases next to each other. So I get 2 to the second times 2 to the third times x to the second times x to the negative 4. So 2 to the second times 2 to the third, that's 2 to the fifth. And x to the second times x to the negative 4, we combine these exponents, 2 minus 4, to give us x to the negative 2 power. So 2 to the fifth power stays on top. To get rid of the negative exponent, we flip x across the fraction bar. And our answer comes out to 32 divided by x squared. It's really important to keep track of your exponents and keep track of your negative signs. There might be an example that you will see. By might, I mean there will be, where you'll see something say 2 to the blank exponent times 2 to the third equals 2 to the negative 1. And what they want you to do is they want you to fill out that blank. What is that blank? What number has to go there to when we multiply these numbers with the same base, we get an exponent of negative 1? We'll call that an x for now, and we'll solve for it. 2 to the x times 2 to the 3 equals 2 to the negative 1. Okay. So since we have the same base, we know that these exponents get added together. So x plus 3 equals -1. So to get x by itself, we subtract 3 from both sides, and we're left with x equals -4. So that's going to do it for our video today. If you have any questions, feel free to email me. Oh, I'm sorry, one more thing. If you get something like 3 to the second power times 3 to the blank equals 1, you might be a little confused. Because 3 and 3 have the same base right here. A base of 3 and a base of 3, but we have a 1 here. So there's a certain property we have to remember, and that is that any number, this works for any number at all, any number to the 0 power is always equal to 1. Any number to the 0 power equals 1. So we can change this 1 right here to have the same base as 3. So this would be 3 to the second times 3 to the x equals 3 to the 0 power. So now that we're here, we have to combine the exponents. 2 plus x equals 0. Subtract 2 from both sides. X equals -2. And now that will do it for us. So make sure you go to the bottom of the video. Right underneath the video, there's a Google form for you to fill out. Just a couple of questions. You have to answer that to get full credit. See you guys.